There you go.
Welcome to the April 26, 2022 session of Tangerine SDR and HamSci technical session. My name is Dave, KV0S, and this week I've been working on little projects here in the Ham Shack, both Raspberry Pi oriented and RTL SDR oriented and some ESP32 oriented. So those keep me busy. And that's about it. So next on the list is Nathaniel, W2NAF. Go ahead, Nathaniel.
Thanks, Dave. It's been a busy week. I've started working on another proposal with Case Western people for the Eclipse. So we're trying to get along with that. I've continued working with students. I made some ray trace plots for Joe W7LUX. Jonathan Rizzo came over to my house on Saturday and hung out with me, and he helped me install Starlink. So I'm actually connected to you via a Starlink connection right now. We also did work on his VLF receiver, which I think substantially improved the situation. And he can tell you a little bit more about that at the end. W2NAF, back to Nat.
Fine business. Next on the list is Dave, KD0EAG. Go ahead, Dave.
I hope I've left my
Yes.
stuff on because my mouse battery just died, and the replacement was worse than the original. But I don't know what I've been doing. I guess I've worked on some ESP32 tracker projects amongst other things. And I've also been doing a lot with trying to do remote data collection via LoRa and things, but keeping fairly busy with that. And then sent my wife off again to Romania for the 6th time in about a year. So that's it for me.
Okay, next on the list, we have Mike, AA8K. Go ahead, Mike.
Well, thank you. Greetings to everyone listening. Back to you, Dave.
Fine business. And then next on the list, we have Bill in 8ET. Go ahead, Bill.
Yeah, I've been scrambling around trying to get everything going. I was phoning all weekend. My computer I'm in a different location. You probably noticed my background's a little different. I'm downstairs to the upstairs, and I just got this thing running down here so that I can come on. And I wanted to find out what I've been getting in the grate that I think I got running, and that's all upstairs, so I can't show it to you on this computer, but I can ask if somebody can look on the WWV site and see if the data is being uploaded from node 41 for me, because I haven't been able to check. But and I've got this other computer down here. I'm trying to get the case off, figure out what's wrong with it, and pretty much tearing my hair out. So I think that's about enough. And hopefully the only thing that contagious from me to everybody else is Dave's battery and his mouse going bad, but everybody else stays healthy. Back to you, Dave.
Okay. Next on the list is Bill, AB4EJ. Go ahead, Bill.
Okay, thanks, Dave. Good evening to the net. Just working a bit on stuff for the NASA project and also working with the students. This is their last week, trying to get the bulk of the functionality for the central control system in good enough shape so that I can work on it with the graduate student during the summer and get ready for maybe having some beta testing in the fall. That's what we're pushing for. And we're figuring out, okay, we're going to accommodate break stations as well, and also be able to handle 2 or 3 different kinds of continuous uploads and figuring out when.
Whoa. Bill, your mic just went off. I guess.
How's that?
That's better.
Yeah, okay. Anyway, I mean, that's just That's all it is. I mean, there's very little else to report, so back to Nat.
Okay, next on the list is Dan in for XWE. Go ahead, Dan.
Thank you, Dave, and good evening, everyone. Just spent some time this week listening to FT8 and Whisper and kind of marveling at the incredible propagation conditions most days. And also did a little bit of work trying to understand SOAPy SDR better. And I mean, it looks like it's something we might be able to use in the future for the TangerineSDR. And that's about it from here. Back to you, Dave.
Fine business. And next on the list is David in one HAC. Go ahead, David.
Good evening, everyone. Been working on getting our Baffin Island system together. I'd mentioned before that we were having trouble with it, the Raspberry Pi crashing the USB interface. Turns out, looks like it was the Sabrent SATA to USB adapters we were using were crashing. Didn't like running the SSDs. We switched to StarTech, and the problem went away. So more shall be revealed on that one. Also working on cold weather power systems. So back to Nat.
Well, interesting stuff. Next on the list is Gary, AF8A. Go ahead, Gary.
Yeah, good evening, everyone. Just fooling around trying to learn about the I2C specification after listening to the discussions on the temperature sensors last week. So looking at AX and MAX and bits, and that's about it. Back to that.
Well, good stuff to learn. Next on the list is James, KG4 DSG. Go ahead, James.
Evening, Dave and the group. Not much to report here. I do have a question for Dave McGaw. Do you have any idea what the controller chip is in those two different USB adapters, or have you gone that deep?
I do not. They're pretty well buried. So
that's true. Okay.
Actually, I have a StarTech that has died, so I can tear it apart. And then the other ones that aren't of any use to us, I suppose I could tear that apart.
Tear it apart if it doesn't work. Yeah. It'd be interesting to know if there is a difference.
Oh, there's got to be. Yeah, they're very different behavior.
I've had various brands. I haven't seen any problems like that, but it doesn't surprise me that something like that might arise. Other than that,
I don't know if the size of it makes a difference, but we're using 2 terabyte SSDs, I think.
It shouldn't.
And we've been using that same case by Sabrent on our AM Doppler system, but it's a much smaller SSD. But that's been reliable for us.
Yeah. Is it a case that holds like a 2.5-inch drive?
Yeah, it's 2.5-inch drive, 5-volt only.
Okay.
And I do know that these SSDs draw very high currents at times. Their average is like 100 milliamps, but it can draw like an amp and a half.
Yeah.
In spikes. So I think that's what's killing them.
Okay. Good information.
But, yeah, I think that it's something to keep track of what works, what doesn't work for people.
I know that came up, I guess maybe it was last week. Did you say that you were running external power? You're not powering over a USB on those?
They are running over USB. There is no provision for external power straight to the drive.
They do sell external USB power adapters. Are you aware of that? The power leads are separate from the data leads, and you just stick a 5-volt supply on it. They are out there.
Right. Well, we're trying to package this all up in one box and
sure.
Trying not to run too much. I'm using a USB hub that is not current limited, so it's not a matter of that.
Oh, okay. Okay. So it is powered externally, effectively. You're not pulling power from the Pi.
Yeah.
Okay. Back to the net then. Thank you.
Okay, next on the list is Jay Schwartz. Go ahead, Jay.
Okay, howdy, everybody. Not a whole hell of a lot to report from up here. Just looking forward to Hamvention, and hopefully we'll see everybody in a few weeks with the pilgrimage for the first time in a couple years, and we can all quaff a cold 807 together down there. Take care, and we'll catch you all later on down the log.
Okay, next on the list is Jim K4BSE. Go ahead, Jim.
Good evening, all. Well, I've been trying to get a couple of HOA hidden antennas up in my backyard, and Dr. Murphy has been with me every step of the way. So it is going slowly, but I'm trying to put up a off-center fed dipole just to get a little bit lower VISWAR at my favorite operating frequency, so I can run my linear without worrying about burning up the transformer. And also a 10-meter vertical dipole, so I can hopefully participate better in a local 10-meter net that I have trouble copying everyone now. So I'm coming close, but like I say, Dr. Murphy has been my constant companion, and still is, and I'm still waiting for some more connectors, and hopefully those will be in soon. But the DigiKey login website is down, so I can't check it this evening anyway. Back to net, K4BSE.
Okay, next on the list is Joe K7LUX. Sorry, W7LUX. I did
That's
that
all
last
right.
week.
Yeah. Good evening, everybody. Been spending my time getting ready for the Flagstaff STEM celebration. They've asked us to come, and we're going to provide an amateur radio operating station, Morse code practice, and we're going to concentrate on ionospheric studies, propagation and such, and try to get some of these youngsters and maybe their parents involved in this. Very, very much appreciate the help I've gotten from Jonathan and from Nathaniel. Jonathan sent me some nice VLF traces, and in fact, if you'll let me share my screen, I've got that here, and let me see what has happened. Select a window. I'm lost.
Make sure you pick like screen one and then hit share.
Well, I
Click it.
have the thing stacked up. It just doesn't want to work. Let me, I'll try this one and this one. I can't do both of them. So there we go. Just do share. And this was the X 1.3 solar flare on the 30th of March. And you notice the reaction from the grape monitoring 10 megahertz WWV, and bring this up. And at exactly the same time, Jonathan recorded a nice spike in the VLF signal from NAA.
I think we're only seeing your one figure here. We're only seeing the VLF plot.
Okay, the VLF. So why? Please move this window away from the shared application. Whatever that.
I think what you need to do is you have to hit stop share, and you have to share your entire screen, not just one application.
Okay, I do not know how to do that. I
just hit the share. Hit the share. Yep, and then just hit share again.
Do we have both of them now?
Yes.
Yep.
Oh,
Perfect.
super. Okay. Anyway,
Okay,
here's
great.
the 10 megahertz from WWV on the 30th of September. Here's Jonathan's nice spike, nice shark fin spike. And in fact, the mine is basically an upside down shark fin in the signal strength from the 10 megahertz signal. Almost exactly mirrors Jonathan's. So boy, a big vote of thanks to Jonathan and to Nathaniel for that absolutely gorgeous 2 minute little movie he sent showing the signal path through 24 hours. Anyway, thanks to both of you very much. Thanks, Dave.
You're welcome.
And how do I unshare? Stop share.
There we go. Okay. Next on the list is Jonathan, KC3EEY. Go ahead, Jonathan.
Hi, everybody. It was quite a busy week. Joe, thanks for the recognition. That was some really nice results there, and that's actually normal, where you would see the enhancement in propagation in VLF and a decrease in propagation in HF. So that's a really nice result. I provided 4 plots to Joe for 4 different dates. As Nathaniel said, I was over his house on Saturday, and we installed his Starlink system. That was actually pretty neat. The install went really well. It came out nice and clean. It's super cool how it actually works. Really neat. We would see the antenna actually tracking the satellite that it's on, and the antenna would actually move, and even though that it would move slowly, it would we would come back and we would see the antenna moved. It's really cool, and it's kind of crazy how much bandwidth or how much throughput that you actually get out of that system. But the install came out really nice. Also, while I was there, we worked on the VLF system. What I had to do was we had planned on removing the ground wire, and also I purchased a copper ground strap to attach to the mast to use as a permanent earth ground connection for the antenna. So I added that, and the results were actually quite remarkable, and they show up in the plots. I'll share the screen quick here. This is this one is a plot of this one is a plot of the 180 hertz mains, the 180 hertz mains harmonic. You could see here the wild signal strength, and just before 20 UT, there was a large spike. That was me actually working on the antenna, and after me and Nathaniel, we pull that ground line. The results are really nice. You can see the nice flat lines. This nice flat line here. So I'm actually really happy with the results. Actually, if you zoom in, I have that here. It shows. So this spike here is when I actually disconnected the earth ground connection from the earth ground. So it picked up some hum, some extra power line hum, because it didn't have a reference. But after that, you could see just the lower hum levels. So it was a really nice result. Even before we took it out, I mean, it was the levels were actually pretty high here, and it made a difference in the signal. The biggest difference, which is really cool, is in the spectrogram. So I'm going to scroll here. So you could probably see the first part of the spectrogram. This is the signal with the ground with the ground line in, you could see there's a lot of harmonics past 6, from around 6 to 13 kHz. The filter actually filters some of it from 60 hertz all the way to 6 kHz, but there's still quite a bit. And as we go along in time, as we get closer, you could see here these spikes here. These can everybody see this little a dark spot here?
Yep. Mm-hmm.
Okay, so this dark spot is actually when I touch the antenna. When I touch the antenna, I load the front end, and these bright spots here, that's the microphonics from me touching the antenna. So this is where that I was playing with the antenna here, so I was here. I want to show the so this portion here. You could see these regions where there's not a lot, where there's reductions in the background harmonics, and this, I believe, was when Nathaniel was actually pulling on the wire, so you can actually see each pull out of the ground as Nathaniel was doing it. So it's really cool. And then you can see as time goes on, it gets lesser and lesser. This is where I was messing with the antenna. I disconnected the earth ground and I connected it to the ground strap. All this other interference back here, this was me trying to put the ground strap on because I wanted to get good contact on it. And this is after I got the earth ground connected back up, and you could see the difference, just how much more clear. The spherics you could see very, very clearly. There is not a lot of background noise. You can see here there's this is a loud spheric modulating the hum filter, but that's normal. But it's really, really, really nice. And you could actually hear it. You could actually hear the difference. It sounds so much better because you don't have a lot of that harmonic content. So now my hope is I'm going to get more natural radio signals. I'm going to get amateur signals. This is really quite exciting and a big improvement. The next step for us is we have to get we need to get the GPS antenna installed. We just have to find a mount for it. Nathaniel ordered the remaining parts, and we will get the GPS antenna installed, and we'll be good to go. That's
And
all
we're
I
gonna put in Radio Jove too.
Oh, yes. So we ran three RG6 coax lines along with our Cat6 lines. So 2 were reserved for orthogonal loops for the Tangerine and the Edis. And the third was extra. So the third will be used for a Radio Jove antenna that will also be installed. Keeping isolation in mind, I found these a really nice 75 ohm isolation transformers from Mini Circuits. And they have pretty good performance, and they will keep everything nice and isolated, maintaining the isolation to the VLF receiver and the local ground around it. So once we get some more information on that, we will be installing the Radio Jove antenna, which is going to be fun. It's always fun to install antennas. That's all I have. Back to the net.
Okay, next on the list is Jules, K2KGJ. Go ahead, Jules.
Good evening, group. Not a lot of ham-sci activity this week. I had to rebuild my old Sony Walkman Pro cassette recorder to recover some old audio files from 20 years ago. And then the other problem was some serious dry rot in the sill on one side of the garage. It has to be taken care of, so I'm kind of in the middle of that project. Other than that, back to net.
Well, fine business. I was doing something similar this week. I was trying to read floppy drives from the 80s and 90s. And most of it came across. I was surprised. Anyway, next on the list is Michael Howen, AC0G. Go ahead, Michael.
Good evening, everybody. Dave. I've been banging my head against ESP32 programming this week. Rearranged my receiving radios a little bit and been trying to organize my shack so it's a little less cluttered. Nothing further here. Thanks. Back to net.
Okay, next on the list is Noel, WB0VGI. Go ahead, Noel.
All right, good evening, everybody. Not a lot to move. I turned my picture off here. The only thing I did was I'm working on reducing the power of the magnetometer and connected the RM3100 to a Raspberry Pi Zero, which is the new one they have out, the 02W, which does have Wi-Fi. And so that is running, and that even reduces the power down even further. And those of you that were working with ESP32s, I just got one this morning or this afternoon. And so here it is. And so I'm trying to figure out if I can get that to work to try to reduce even further the cost and the power that we're using for the magnetometer. Thank you.
Fine business. They're interesting little devices. Next on the list is Scotty, WA2 DFI. Got it, Scotty.
Hey, Dave, can you hear me now?
Yes.
Okay, very good. So this week, just more of continuing from last week. We got the data engine adapters and are on order, as well as the and I don't know if I had this week. We got the last part for the Magneto Pi boards. And I don't know if I had said that last week. I'm not sure exactly when they came in. You know, the weeks kind of blend together. Anyway, we get this little box from Mauser, and inside are 500 of the I2C transceivers. Little reel, like yay big. So anyway, we're proceeding with the build there. That's the order's been placed already. That's the estimated completion is 5 weeks, which will be the week after Dayton. So sorry, can't make it. But at any rate, we'll have them to sell almost immediately after Dayton, after Hamvention. So take a look keep an eye open for that.
For the magnetometers, right?
Magnetometers, right.
Great.
We just started the build of 250 kits. So
woohoo. That'll be in time for me to report on that at the CDAR workshop.
That's how many weeks after Dayton is that?
CDAR is in the middle of June.
Oh yeah, you'll have boards by then.
Yeah, I can take them with me to Texas.
Yeah. And you should be able to have a data engine adapter by that time too. Although we're next, of course, is going to be the firmware for it. So that will be the next topic. But at least we'll get the hardware out of the way and off my heartburn plate here of not being able to buy anything. And the other thing that was done is I just got a note today from the CAD guy. We're going to have a review tomorrow on the loopback boards, and they're necessary to build the data engine when the parts come in. And also they'll be useful for testing the data engine adapter. So, and if I can share my screen here, I can show you what we've got here for So this, as far as I know, is the first instance of a leaf board. So high-speed connectors down here on the bottom. This is a bottom entry cable connector, so the socket. So what you don't see is the holes here for all of the pins that come through. So what you do is you insert this in the M.2 connector on the data engine or the data engine adapter. Actually, it's not on the data engine adapter, take that back. On the data engine, we have a MICTOR connector for the VLF module. Anyway, you stick this in the M.2 connector at an angle, with the board at an angle, and then you tilt it down and push this over the Raspberry Pi header. And then these two screws, these two standoffs hold the board in position. And all this is just a loopback board. So there's LEDs to indicate all the ground and power pins down here. And then there's 3 comparator circuits that will tell you what voltage these 3 VCCIOs are at, whether they're at 1.8, 2.5, or 3.3. The different color LEDs light up to tell you what they're set to. So it'll detect what the data engine is strapped to, providing the voltages to the leaf module. And then see the clock module. This is this is the blow up here, but it's basically the same kind of circuit for the VCCIOs on the clock module. There's 3 of them. And then these are the LEDs for the power indicators. And what you don't see is all the loopbacks, all the traces that loop back these connections here. And that pass fail will be determined by the FPGA, which will send signals out on half of them and read them back on the other half and make sure you get continuity, and then shift them over by a bit, do walking ones or walking zeros to make sure you don't have any shorts. So we'll be able to test all these connections to the data engine on the M.2 connector. This is also an M.2 connector. Then last but not least, the RF module. Same thing here. We have only one VCCIO here, and then of course all the power pins. And these 3 boards, this one, and this one, are all the exact size of the real boards that we make for when we build a clock module or a leaf module or whatever. The physical size is the same. So we'll get a chance to try out the mechanical fit of all the boards together. We do finally get a data engine. And we're going to have a review tomorrow, and I'm expecting that if everything goes well, well before the end of the week, we'll be able to order these. And so these will come in about the same time, about the end of the month. These are simpler, and we also have all the parts. Nona right now is going through we actually have, this will be the 5th, 5 boards in progress right now. So we have the 3 loopback boards and the data engine adapter and the see, I can't even keep them all straight, and the Magneto Pi, and we've got all the parts for all of them, and she's just going through to make sure that we didn't miss any, or have a wrong part or anything like that. So when we hand him over to the contract manufacturer, he doesn't give me a call at 5 in the morning, which is when he starts, and says, "Hey, we need this part." So like, and actually on the RF module, it's funny because we bought 26 of the connectors for 25 boards. We had 1 spare connector, and they're really expensive. They're about $12 a piece. So we didn't really want to buy too many spares. And the CM emails me, he says, "Well, we're short 4 connectors." And we're like, "Well, no, you should have 1 extra." But he says they're short 4. So he says that Mauser shorted you 5 connectors. Well, so we go off and we order 5 more connectors. And then the next email comes in right after I hit the order button. He says, "Oh, wait, never mind. We found them." So, but that's okay, because those extra 5 connectors are the connectors that we're going to use on this module right here. It's on the back side. So we're going to use them all up anyway. So it worked out. Anyway, that is all I have. So if I can figure out how to do this, I'll stop sharing. And back to you, Dave.
Okay, and next on the list is Todd AD0RR. Go ahead, Todd.
Thanks, Dave. Well, I went to a ham fest a couple of weekends ago, and I picked up 3 brand new Bodner GPSDOs for $150. And so I'm the grape that I have now, I'm running on the DRF. So I'm in the process of building another one so I can run it at 10 megahertz and run the normal software on it. So I'll be monitoring 5 meg with the DRF and 10 meg with the normal weather station. So anyway, so I got a little bit of surface mount work to do, and which I enjoy, but I guess that's my big project.
Well,
back to you.
Fine business. And last on the list, we have Tom in 5EG. Go ahead, Tom.
Good evening to everybody. Mostly been working on open HPSDR drivers for GNU Radio. A lot of chatter on the GitHub, and I've started the porting effort to GNU Radio 3.10 for the drivers. Yeah, there's a fair number of changes that are going to be required. So that's about it for the week.
Fine business. Sounds like an interesting project. Anyway, so if I have not missed anybody, we should be open for general discussion.
I'd like to make a request. So at the Hamvention this year, we're going to have, in addition to the forum discussions, forum talks, we're going to have some booth talks over in the Ham Radio 2.0 area. And I would like to know if anyone is interested in giving a booth talk about some ham sci or tapper related topic.
How long are the talks, Nathaniel?
You're up to an hour, but
An
you
hour?
up to an hour. So my recommendation is that you make the talk 20 minutes and you allow for 10 minutes of questions, but the maximum length your talk can be is an hour. So I can show you. So I think if you haven't seen this, I know Tapper has their own booth, but HamSci, I have this page and you've probably seen it. If you are interested, I'm putting a link in the chat. If you want to know how to participate in HamSci sort of activities at Hamvention, you can go to the link in the chat and you can follow the instructions here. There are instructions on how to get your lab coats. Our booth is actually going to be right next to the Tapper booth. So if you're at the Tapper booth, you're also at the HamSci booth and kind of vice versa. But as I said, we also have these booth talks. So I just penciled in myself. I penciled in one of my students for booth talks. And we're alternating between Ham Radio 2.0, which is being run by Neil Rapp. And he's filling in these talks, and he actually has a list, another web page here that has his talks listed. I think here it is. Yeah. So what I have to do is I have to copy his titles into my page over here. But wherever it says HamSci, we have open slots. So would anyone be interested on talking on anything? So like I know David McGaw, people might be interested in the things you're doing with the antennas.
Yeah, I'm not going to be there this year.
Oh, I guess it'll make it difficult.
Yep.
Yeah, but that would have been a good possibility.
Yes, I'd love to do that, but unfortunately,
yeah,
won't make it.
Yeah.
And
If you-
Nathaniel, if you end up with a slot open, we're going to have Jonathan's talk on the VLF receiver on recording. So we could actually play that again if it's okay with Jonathan.
Yeah, I was actually just going to mention that it could be used for both. Yeah, it's not really necessarily hardware heavy. It's more about the applications that you could do with the Whistler Catcher module, which would include all the nice recordings and everything that we have so far. It'll talk about, natural radio signals, VLF transmitters, and some amateur transmissions below 9 kilohertz. That's going to be a recording that I'm going to give to Scotty. It'll be 15 minutes long. If that would work, I don't know if you could play recordings.
That is a possibility. I think I'd like to prioritize filling it with live people first.
I was
But
just thinking if you couldn't fill it, then you might be able to not have dead air.
I have a feeling we'll be able to fill it because, I'll talk to the grape group on Thursday, and I can probably send an email out to the listserv again, trying to recruit people. But you're absolutely right. If we can't fill it, we can have Jonathan give it. And yeah, we have our forum speakers, maybe some of them I could have also double up as well. And that would give them some practice before the actual forum. So
is the forum, the booth talks are on Friday or Saturday or both?
The booth talks are on both Friday and Saturday.
But the campsite workshop's Friday, right?
The forum?
The forum, yeah.
The forum is on Saturday from 2:50 p.m. to 3:50.
Oh, okay. So most of the booth talks will be before the forum then.
That's right. Yes.
Okay.
So we have for the forum, we have Veronica is talking about her observations with the grape. Scotty is giving our TangerineSDR architecture and hardware update. My student Diego is talking about his climatology of TIDs. And Bill Engelke is going to be talking about detection of TIDs with the machine learning. So Bill, if you wanted to, you could demo or talk about the central control system or software updates with the Tangerine. I know you've got some of that going. If you wanted to do two things, if not, that's okay too.
Yeah, I'm struggling. Frankly, I'm struggling to keep up with what I got on my plate right now. I mean,
Yes.
I'd love to be able to do more, but
Yep. So that
I'm running out of hours.
I understand. No, I think that's just fine. If anyone has grape data they want to talk about. So anyway, I will turn it back over to the group, but if you are in a position where you're interested in doing this sort of thing, feel free to email me and we can talk about doing a presentation. Back to
Also,
that.
those are going to Hamvention. The Tapper AMSAT banquet is on Saturday night. It is Saturday, right? Right, Dave?
Yes.
Yes, it's us on Saturday. No, on Friday night.
Friday.
Friday night. Yeah, so all you show up on Saturday, you'll be very disappointed.
And how much are tickets, Scotty?
They are, I'm going to have to look because the prices have gone up considerably. I think they're $54.
Okay.
Because of the cost of just the basic and really we're cutting it right down to making nothing on it. Just it's something that we have to have. That I mean, an event we have to have. Yeah,
I understand because from organizing the Hamsci workshop, I sold the tickets for $60, and that's pretty much exactly what they cost.
Yeah. It may be. I think we tried to keep it under 60, but we didn't make it by much. We tried to keep it under 50, and we tried cutting the menu back, and it still came in over 50. So we said, oh well, people don't want to eat beans for $50, so we're so.
I'll try and arrange it so my students and I can attend to that.
Yeah, okay, and the theme, let's see if I got it on here, what the price is. Anyway, the theme is going to be celebration of life for Bob Berninga.
Yeah.
And let's see.
And
Scotty, the web store at AMSAT says $57.
57, okay, that's what it is.
And you need to order ahead of time.
And you have to order ahead of time. If you show up there and you want to buy a ticket, you will be turned away. So, because they have to give the count to the catering center before Hamvention starts, so they can't sell tickets at Hamvention. So And what I was going to ask, if anybody has had any interaction with Bob during his past long history with Tapper and with MSAT, please email me, because we'd like to reserve a slot for you to tell anecdotes or whatever other experiences you had with Bob. Bob was quite a character and had his hands in many pies. So there's lots of I'm sure there's lots of stories out there if we can just get the word out to people who are interested in coming and talking a little bit about their experiences. And let's see what else. I guess that's it for Hamvention. Looking forward to seeing everyone. It's going to be great. After 2 years of
in person. Woo.
Yeah.
It's gonna be awesome.
Especially having HamSci right next to us, it'll be great.
Yep.
And having hardware to show
real boards.
I know, it'll be so exciting.
That was another thing too, is we actually built 2 of these boards with no GPS on them. And I'm going to be ordering the other 2, the low cost, the El Cheapo and the mid-grade GPS. And we're going to put one on each, and John's going to characterize the performance. The El Cheapo one is going to be pretty much used just to give you good frequency stability, and that's about it. And the mid-grade, they're both single channel ones, as opposed to the one that we built most of the boards with. So that you're really going to want the dual channel one for the HamSci Space Weather Station, so you can do TEC measurements, right, Nathaniel?
Mm-hmm.
And in the absence of that, I'm not sure what the other ones are. Well over $100 cheaper for the mid-grade and about $150 cheaper for the low end. So it's a significant cost savings. Don't need the capability. So, but anyway, we're gonna test those. We're actually talking to in negotiations now on getting a volume build of the low end one, because I'm figuring that's probably going to be the non-space weather station version is going to be the higher volume in the end, because it's so inexpensive. So
yeah, Scotty, I saw John Ackerman's note on his initial testing of the board. It didn't look particularly good.
Well, he's
still
going
to tweak on it.
He's still tweaking on it, and there's lots of parameters to set. So the jury's not in yet on the performance level.
Yeah, I was a little concerned about that when he told what he was doing for architecture, but
yeah, it looks like from the first pass, the close in ADEV plots are not as good for the first the first 10 seconds, because basically our oscillator isn't quite as good as like the Leo Bodnar.
Right.
But
I thought we needed a good outside external oscillator. But
well, we thought we had one, but it wasn't quite as good as the one we can't get. So, but of course, getting it means it's not very good at all. So,
right.
And so when you get past 10,000 seconds, though, our ADEV plot continues on down. And
right. Yeah, its long-term stability is going to be fine, but using it as a A to D carrier, here to use sample clock, I think it's going to need to be cleaner. We'll have to see what he can work out.
And of course, then there's always the alternative of, if you just want a really, really low phase noise clock, we can build a basic clock module that just has a VCXO on it, and no fancy, no GPS or anything.
No, you need GPS and you need the good oscillator.
Well, you need GPS for some things, but not for everything.
No, well, the sorts of things I do.
Yeah,
you need GPS and a good oscillator.
Anyway,
that's what the
beauty of a module. If it doesn't work and as well as we like, then we redo it.
Right. Well,
come out with a better one.
Yeah, I can't remember if he left provision in there for adding an outboard oscillator and locking it.
There is.
Okay.
So you can.
But that's going to increase the cost.
Yeah, but at least it'll be possible to do that. And
Yeah.
then we can test other oscillators, and then we can come up with an integrated version using that
Right.
oscillator if we need to.
Right.
So
As long as we got the hooks, we'll
Yeah.
work it out.
I mean, I'd like to say that the first thing out of the gate is always the best and the perfect, but that's not the case. So we give it the best shot and we make it better as we go.
Yep.
So, and I can see lots of room for improvement. And like I said, we made it modular. So when a better, newer one comes out with more capability, especially I expect GPSs to be improving all the time also. Chipsets are going to get better. You're going to be able to just get more performance for less money, for the same money. So that's why I put it on a little board. So you can plug in whatever level you want and we can make improvements. I mean, the same is true for the RF module as well. And as soon as we get data on that, we'll be able to see how we did. So how many hours to Hamvention? How many days to Hamvention?
It tells you right on their website.
I know, that's why I was gonna go look, because I can't. 3 weeks, 3 days. Oh,
Oh my gosh, that's scary.
oh,
So Scotty, are you driving this year?
yes,
I'll have to wave at you at 5 in the morning.
yeah. Probably will be that way too, because Nona decided she was gonna schedule her bowling tournament while I'm gone. So now we're both gonna be gone. So then, the cat's not gonna be appreciative of this, so we have to get someone to come in and take care of him.
Your cat's welcome to, while I'm gone, your cat's welcome to sleep on my Starlink dish.
You have resident animals there that,
Now, did you see the link I put in the chat?
oh, no.
That is so funny, but very, that could be anticipated. Knowing cats.
Yes.
Okay, so.
Yeah, I'm really interested in what the dB loss or gain of the cat is.
Yeah.
How that, how much
that-
dB does it add or subtract
Oh
from the
my
system?
God.
That lends new meaning to a cat dish.
Wow, how many cats can you fit on the Starlink dish?
And have it still move.
So they're just trying to get off the snow, right?
Yeah, and
No.
the Starlink dishes are heated to prevent the snow
Oh,
from
that's
melting
why.
on
Oh,
them.
they're heated, so the cats go for heat.
Yeah.
They're heated to prevent what from happening?
Snow.
Well, that's a cat house then. That's not a Starlink dish. That's funny. So how many dB per animal do you lose? Let's see.
What frequency is Starlink using?
Yeah, it depends on the dielectric constant of the cat.
Well, it's
I
rather
don't-
complex.
Yeah, I was gonna say I don't think cats are a linear homogeneous media for.
But
Hey,
you
you know
can
what?
still be able to
somewhat
come up with a
conductive.
system number.
It just occurred to me, you know what? This is a Cat 5 dish.
Or is it fed with Cat 6 cable?
Well, there's room for one more over there on the right. So
What's the SAR for a cat?
So Starlink is 10.7 to 12.7 gigahertz, according to a random Google search.
Yeah, that's not going to make it through a cat.
Hmm.
Might warm them.
just give them a little more warmth to stay there.
Might poach their gizzards.
So then in the summer, you put a little, after a rainstorm, then you get birds, right? Which then will attract more cats.
Yeah, there's a picture on there of a bird too.
Oh yeah. What is that? It looks like a falcon.
That's pretty impressive. The architecture looks like something like you might have out where you are, Scotty.
So it must be a starling.
Hmm.
Yeah, it does look like it's out where I am. And you know who posted that?
No. Do you?
No. It does look like a Southwest kind of picture though.
Yeah, it looks like a peregrine.
All you need is about 500 watts of transmit power. Have lunch. And wait till the bald eagle lands on it. You better turn your transmitter off.
Mm-hmm.
That's way funny. All right. I got to bookmark this page.
Yeah, but the question is, at those frequencies, there is such a thing as RF heating. So
Yes.
I'm wondering, are we talking about roasted cat, parboiled cat, just simply warmed over cat?
Now,
Can't be very much power.
Don't go off the rails here now.
500 watts is kind of low for a microwave oven, but
See, like if you want to see a big fight start, you get on the cat fanciers list and you say, I have a bag of kittens here. What should I do? Drown them or burn them? And then you just step back and wait, and oh my God, it's like World War III. It's funny because they don't have much sense of humor, so they don't get when they're being teased.
Hmm.
Have you seen the YouTube Hyundai commercials? I think they're Hyundai commercials. They don't put them on the air, I think, because they catch too much heat for them. But they had one of one with a sunroof, and the cat jumps up on the car, and the sunroof opens, and the cat sticks his head in the sunroof, and it closes it and kills the cat.
Oh,
This is why they don't publish the commercial, right? Because they'd really have mayhem on their hands if they did that. And they had another one too, where they show a bird's eye view of this Hyundai, and you can hear the pigeons trilling. Like this is a bird's eye view, and then the camera swoops down, and the hood goes boom and knocks the bird right out of the sky.
Whoa.
Because the bird was going to go, poop on the car, so the car's defending itself. So just not airable car commercials.
What was it, 25 or 30 years ago, one car company had a bunch of birds flying in formation, all talking fighter pilot talk with call signs, and they were dive bombing a car, and I missed, and this is Dirty Bird, I've got him, and you see him peel off, and you see the crosshairs like you looking up through a heads-up display coming in the car, and then the bird looks up and goes, oops, and he flies through the garage door, and out the other end of the garage door you just see his beak, and it goes, medic.
So what commercial is that for?
It was one of the car companies, but it was something. Now, if you really want to see a really serious, a really good humorous commercial, this one goes back to the 1980s. The Detroit Zoo. It's on YouTube. Look for the Detroit Zoo commercial, and it's a bunch of animals. The keeper comes around and goes, 5 minutes, there's just 5 minutes to opening. And then you see a bunch of animals and various animals, and they're all with superimposed voices of famous actors. Like you see penguins walking along, and one of them turns its head to the rear one and goes, no shoving. Another one goes, I want to talk to my agent. And then you see an alligator goes, let me talk to your agent. And it won several awards. It was seriously funny.
Is it a Super Bowl commercial or?
No. Detroit Zoo.
Okay.
The Detroit Zoo. And I think it was copied also. It was the original one, and other zoos copied it.
Oh, okay.
Yeah, I posted a link to a video I found that talks about how SpaceX actually gets the satellites out of the string up to their final orbits. It's really kind of incredible. And they've got 1,000 of them up there now. But they raise they stagger the raising of the orbit so that they actually space themselves out across the orbit. Somebody's got some serious math skills, put it that way. Keep it all lined up. The video is.
Speaking of math skills, from the ham sci workshop, Dr. Scove, Whiskey X-ray 6 Sierra Whiskey, when in her presentation was talking about with the solar event from earlier this year or last year that actually, raised the ionosphere, raised the atmosphere, and is causing extra drag on some of those Starlink satellites, and it's going to either has burned them up or will burn them up prematurely.
Well, they lost 40 on one launch because of a solar event.
That's what I was thinking of.
Yeah, they 40 out of 60 disappeared. They're not high enough to stay up there very long. They're going to have a constant replenishment operation. They're not going to stay up there more than 5-10 years, maybe. It's really it's incredible animation on this video. You ought to check it out. They just kind of, when they release the satellites, they just kind of float away.
Can you post a link in the chat?
Yes, I think I
Please.
did. Yeah. It's about 15 minutes long, I think. I always wondered how they got them out, because they don't have thrusters, really, not significant thrusters, and they're all bunched up when they let them go. And how in the world do they get them to final orbit? Well, this thing explains it. They stagger the raising of the orbit so that they actually spread themselves out, because of the different velocities on the orbit speeds. And then they get them all lined up in a grid. It's really kind of amazing. So something I found a couple weeks ago.
Oh, there was one thing that I wanted to mention quick. I'm going to share my screen. I wanted to showcase what a false event looks like. So the event detector of my VLF receiver is looking for either it's looking for a Whistler curve using hue transform, or principal component analysis, looking for rising signals. So this would be a situation where you have rising signals, and you might wonder what this is. Well, Nathaniel and I actually saw this event in real time, or we heard it. So this is the vacuum, or the motor in Nathaniel's vacuum cleaner starting up. Rachel was vacuuming in the other room, and I was just talking about these false events, and then we heard this whizzing sound. We were listening to the stream, and this is actually the motor in the vacuum cleaner starting up. It's actually cool to see how many harmonics there are. So this lower line here, this is the fundamental, and then this is the first harmonic, and you could really see the amount of harmonics that motors generate, and this is why that power lines are just filled with mains harmonics, and usually this is where a lot of them come from. And it was really cool that we were just listening, and we heard the whizzing sound, and Rachel was vacuuming, and actually as she was moving the vacuum, you could hear the motor pitch going up and down. We also heard the frequency going up and down, and then when she turned off the vacuum, it eventually stopped. So this was actually pretty cool. These sorts of things just occur in the environment. Actually, I clear out motor starts just about every day, false event detections, and these motors could be vacuum cleaners, washing machines, garage door openers, drills, anything. So this was actually pretty cool. We could see the frequency content. It's actually it's almost it's actually almost a kilohertz wide each line. So,
Hey, Jonathan, how far do you think that propagates?
well, so the antenna was about 320 feet away. Actually, yeah, it was probably about around 350 feet away from the actual vacuum cleaner.
Well, it could have come through the power lines too.
Yeah,
You were so close.
Yeah. What was happening was it was the power lines in the house were acting as an antenna, radiating, and it radiated this in the environment. So,
well, I'd be interested if you disconnected the antenna, and it might be getting just straight into the receiver.
well, no,
That's an easy thing to test.
Right.
No. This was actually coming from the antenna, not the not the input of the sound card.
How do you know that?
Because
it's still an easy thing to test.
Yeah.
Well, so the sound card in the Raspberry Pi is enclosed in an aluminum case.
Doesn't matter. You need to test it.
And it's easy to test.
Right.
This is like trivial.
But there's a lot of conducted interference that you can get, so I would test for it.
My guess is if we unplug it and we run the vacuum cleaner, we're not going to see anything on the input.
I'll bet if I unplug the vacuum cleaner but turn the switch on, you also won't see it.
You run the vacuum cleaner on a battery and an inverter.
Yes.
Yeah, I discovered a interesting, I will use the term loosely, interference source to our receivers at the lab at Dartmouth. The fan, the exhaust fan for the backside of the building is a 3-phase 600-volt motor, which you wouldn't think puts out any interference, except they have a variable speed drive on it, variable frequency drive on it. It puts out huge pulses. I'm trying to get them to retrofit a EMI filter onto it, but it's running constantly, and it's not helpful for our receivers.
There are other signals that my VLF receiver picks up. There's a pulse signal around 8.2 kilohertz, and it has existed ever since the receiver has been installed. It's about maybe 100 hertz wide each pulse, and it's a pulse on and off. So I believe that's a switching power supply somewhere. With the removal of the ground wire, that pulse has reduced significantly.
Jonathan, could you go through again quickly what exactly you changed in the grounding to do such a good job of getting rid of that 180 hertz harmonic?
What I had was, I don't have the pictures right now, but what I had meant to do was connect the earth ground connection to an actual ground strap that you would attach to a pipe.
Well, what do you mean earth ground? Of what?
Of the VLF receiver. That's the other other terminal of the antenna. So the antenna has its antenna element and the earth ground, and it takes the voltage between those 2 points on the.
Oh, so it's a single whip antenna?
Yeah.
I see. And you're working against earth ground. Is that a ground rod?
No, actually, well, that's an aluminum mast that the antenna is mounted on. And I just got one of those copper ground straps and wrapped it around the mast and connected it to the screw. But that wasn't what made the difference. Because before it was, I had one of those garden staples. You know what I'm talking about, for weed fabric. And I had the earth ground connection connected to that, wrapped around it and pushed into the ground. And that actually worked quite well. It worked well at my house and up at Nathaniel's. But once the ground wire was removed, that's what made the difference.
The ground wire to what was removed?
Oh, so there was an 8 gauge copper wire that was run alongside the conduit from the house to the antenna site. And what that was doing was it was taking all the mains harmonics that were local to the house and making their way into the ground and providing a low impedance path directly to the earth ground connection of my VLF receiver.
Okay, you do not have a ground rod at the VLF antenna?
No.
Why not?
Well, the ground rod itself is the mast.
But it's not in the ground, is it?
Yeah, yeah.
How far?
3 feet in the ground.
That's a minimal ground.
Well, with an E-field receiver, you don't really need a very strong ground.
Well, the receiver, the E-field antennas I've seen recommend a full ground rod.
Well, that's obviously the best. But in my experimentation, I've had situations where holding the receiver with my hand acting as a counterpoise was actually very effective. But obviously,
well, I guess you can ship yourself with each antenna that you send out.
Huh?
That's a joke.
Oh.
That's like we used to, when we were debugging logic, there you'd get runt pulses in the logic, and when you put a scope probe on it, the pulse would go away and the circuit would start working. So we would joke, "Oh, I guess we have to ship it with a scope probe."
Well, this was actually, I mean, these sorts of receivers, I've used different designs and played around with the grounds, and Paul even recommended just a small stake in the ground is adequate enough for these VLF receivers.
Okay.
So it was, so it is grounded. It was always grounded. Now it has a little bit better of a ground, but the ground isn't for lightning protection or anything like that. It's for the antenna itself, because that's the other electrode of the antenna.
Right. So the upshot is that when you connect the bare copper ground coming out from the house, you're creating a big ground loop, which induces all this noise into it.
Yep, exactly.
Interesting.
Because so when I built this receiver, I used audio isolation transformers on both sides for the audio line. And I also used isolated DC to DC converters for the power on both ends. And Paul has tested this, and he has found good results because it blocks everything, all the junk coming back from the house, and this ground wire kind of defeated all that. But now we have adequate isolation, and the noise levels are actually much lower. And his
sounds good.
recommendation for grounding, say for grounding other antennas that are nearby, is to use an isolation transformer and connect a local ground, and ensuring that local ground does not connect back to the shield of the feed line. So that's why that he recommended isolation transformers. So for the HF antennas, I found some 75 ohm isolation transformers. With some pretty good
For HF, you're generally going to want to use balance.
Yeah, that's what these are.
Yep, sounds good.
Yeah.
You didn't get a chance to look at those graphs, did you?
Me?
Yeah, the graphs that the data that went on online. Did you look at the graphs?
Oh, I can show it to you.
So
I
just wondering, the graphs, all the graphs that I've seen from other people are fairly smooth and drop off at night. And mine, there's enough stuff going on with the sun though this last week that I think maybe I was seeing an awful lot of events in there.
Right. Right. So this is what I have for your page.
Yeah, no, there's that one over on the right that one. I actually shut things off for a bit, and that
Okay.
I didn't understand what that was, but all this other jumping up and down, is that normal?
I don't think it's. I think it's okay.
Okay. I'll watch and see what happens when the sun settles down the next couple days. And
yeah. Let me show you something that, I mean, this looks fine to me. So Christina's starting to do some nice things with the data. She just sent me these images. Here, Joe. Christina's looking at your data.
Okay.
So she just sent me this plot today. And so this is your data plotted from April 9th through December, through the end of December of last year. And it looks like she's plotting, I'm not sure, I guess this is universal time, but so it's basically one day in every stripe. And then you're using this color bar to be Doppler shift. So blue Doppler shift is positive, red Doppler shift is negative. And so she's seeing the diurnal variations. You're seeing diurnal variations. So, which is sunrise? I haven't looked at this very carefully yet, so I haven't really got it all figured out in my head. So at sunrise, you should see positive Doppler shifts.
Why is that? I haven't figured that out. Sunrise, the ionosphere should be moving up. Path would be lengthening, and I would think Doppler should go down. What am I missing?
At sunrise, I think the ionosphere moves down. The density increases, you're seeing more refraction, the ionosphere is moving closer to the Earth.
Okay. But the F1, F2 graphs day and night show the nighttime Oh, what is it? Lower? Let me think. I've got one of those right around here somewhere. I mean, I agree that there should be some, yeah, the night's higher, day is lower. Okay, so it moves down and you get increase.
And
Okay,
this is entirely consistent with what I've seen in, like, I've been showing Steve Ryer's plots from the eclipse from a few years ago. And whenever I look at super darn data, ground scatter data, you always see the data be out further in range first, and then you see it come closer in range during the day, and then you see it move out again. So this is all consistent with the ionosphere getting lower and moving. So that would imply a positive Doppler shift. So
okay, well, I certainly see a positive one here.
Yep. And then in the evening, you see the negative Doppler shifts. And now you also see a seasonality. So you can see that during April, May, June, you have the most daylight. And then as you move into September, October, November, December, you get less daylight, and dawn and dusk move closer together.
I've got one graph here from Encyclopedia Britannica, I think it is. I'm not sure. Anyway, it seems to suggest the daylight is higher. Okay, I'll think about this, but something didn't jive. Right, I certainly do see increases in the morning and decreases at night. And by the way, my night data is all over the place, but then that could be partially due to getting a WWVH at night.
Yeah, I think we should look at that. Look, we see this is all night data up here, right? And this is kind of something that would be good to explain. We're seeing in, in the summertime, we're seeing positive Doppler shifts predominantly at night. And in the fall and winter, we're seeing negative Doppler shifts predominantly. And I'm not sure that I understand that, or that I really understand all this variability, but there's clearly this season, there's clearly more positive than over here.
Okay.
I think that's very interesting. So I guess one of my points is, Bill, if it's kind of hard to really understand what's going on looking at any one single like day of grape data. But as soon as after you take a whole year's worth of data and you put it in a plot like this, I think Christina did a great job with this.
Yeah.
Once you put in a plot like this, you can start to understand it a lot better. And you can start to see, like, I really wasn't expecting to see this sort of split behavior at night in the Doppler shifts. Like there is something systematic there. It's not all random.
Nathaniel, did you notice that you were cited prominently in QEX this last issue?
No, in QEX, I didn't know that.
Yeah, there's a article. This is the latest one, May, June 2022.
Really? What was the article?
Estimation of ionospheric drift velocity by Doppler measurements by a couple of guys in Germany.
Oh, wow.
And the first two papers they cite are you and Christina's.
Well, that's very nice.
Yeah.
It's kind of cool. We're really getting good recognition.
Mm-hmm.
I was an invited speaker for the Space Weather Week student night. So I was on Zoom right before this, giving a talk on that about ham sci.
Click on the click here to read QEX and see if you can get the current issue.
I should read the late QST on the RQX.
There it is.
Read the latest QEX here. I click that.
All I know is the last version of paper.
Yeah, it's yeah, page
QFT.
26.
I just got QST and the paper is lousy.
Well, there was actually a discussion about that on, I think,
Right.
on the FRC, Go FRC. Did you hear that?
I know it's, I expected that to happen, and it did indeed happen.
Yeah. Yeah, this is great. Yeah, they told us RIA N2RJ was saying that the paper issue is a supply chain issue, and the cheaper paper was actually more expensive than the regular paper. So
Well, during shortages, we'll look at all the trouble that Scotty's had.
I know.
But my Sky and Telescope came through just fine.
Huh. Yeah, I don't know.
Yeah, Sky and Telescope's gotten caught up.
I've got, this is great. I should actually, this is really good. I should probably read this. Estimation of ionospheric drift velocity. That's like what SuperDarn is doing.
Yeah, they're using 3530 kilohertz signal that they transmit, it appears, and then yeah, basically NVIS, I think, and then comparing it to a local ionoson.
Yeah, this is great. Well, that's nice. Christina sent me another image that I thought I wanted to look at that was similar to Joe's, but I think it was John Gibbons. Where did it go? Oh, I know why. It's, yeah, okay, this one. I'm looking in the wrong. There, that one. So this is NAOBJ. So now you have like 2 years.
That's very pretty.
Oh, that's gorgeous. Now
That's
they're
similar
not
to what we're getting with the AM Doppler.
okay. Now they're not seeing the seasonal Doppler shift that Joe is seeing at night. Theirs is very, it stays very the same. Now here there's all sorts of interesting things going on in this, like the winter period. What is this? The winter period?
Summer.
That's the summer. Why would that doesn't make sense? Why would that be the summer if there's less daylight here? That doesn't make sense to me. Where if this is a period
Or propagation during the day on 10 megahertz.
and wait, hold on. Let me download this image. Save image as. I have to talk to Christina about this. What is a DIB bitmap file? Will that? All right, so there's one of them. And then let's go over to Joe's. So there's the other. Let's put these side by side. Not that one. Huh. I wonder why she did that. Look at the color bars. They're flipped.
reversed.
Yeah, why? I don't understand why she would do that. Unless she was like going through 2 different versions of the code and she did it one way and then she decided to do the other way. But that's really funny. But what I don't understand is this is presumably, wait a minute. This is
Yeah, the
positive.
times are inside out also.
Yeah, your times are upside down on one versus the other.
Okay, that's why I was saying, all right, this is daytime, but no, this is nighttime. So nighttime's in the middle here and daytime's in the middle there. Interesting.
Yeah, 1900s noon here.
Okay. Yeah. So noon's on the outer edges and night's in the middle. And it seems like they have predominantly, well, they certainly have a lot of blue, which is negative Doppler shift in the winter here. No, the
That's
summer.
in the summer at
The
night.
summer. In the summer at night, they have a lot of negative Doppler shift. And
Yeah,
that's
the
the same,
ionosphere is rising, in other words.
yeah, throughout the whole winter.
Through the summer.
Through the summer. Oh, sorry. I think it's time for Nathaniel to go to bed. I might be.
Yeah, well, you can be forgiven on this. It's a double twist on this.
I'm like, oh my gosh. I mean, I think, okay, so aside from that, like, I think these are really nice data displays. I think it needs a little bit of work in terms of consistency, but I think it's a good way to go and a good way to kind of understand what the grape is seeing. And I think this is very nice confirmation that it really is seeing geophysical things and we're not just making stuff up.
The sine wave on John's data is very different from mine.
Well, yours is only looking at a half of a year. And
His is
John's
2 years.
is looking at 2 years. So you're only looking at, say, from April through December, which is like, oh boy. From like
And remember, it's inside out with opposite
I'm
polarity Doppler.
I'm not even gonna try. It's just, yeah, you're.
But yeah,
No.
John's looks really interesting, and of course, it shows what you expect. Where the what's red on John's is very abrupt, which is the morning, and then the evening change is much more diffuse. Because the reionization happens very quickly when the sun hits the ionosphere.
And you can see that here too.
And that's the diffusion on that end.
Yeah. Christina is
That's
going
what
to
I'm
be able
saying.
to write a very nice paper with these, I think.
Yep.
Yeah. And Joe, you were concerned that your data wasn't being looked at, right?
I don't think you had it.
Well, now we're looking at it.
Right. There's 3 more months that you should also have.
Okay. You'll have to,
January, well, actually from December 28th on up to today.
yeah, I'll have to check with Christina on that. Oh.
And sorry about the dark areas, but I switch antennas back and forth to get on the air frequently.
That's okay.
And sometimes they don't get switched back quite as accurately as they should have been.
Yeah. I think it will also be interesting to kind of line these plots up geographically. So you see like the eastern part of the US, the western part of the US, and I think there might be some very interesting ways to present this data.
Well, I'm at 35 degrees north, so that's a couple of degrees south of you people.
Yeah.
Yeah, it will be interesting to line them up with latitude and longitude and
yeah,
see how they shift.
Yeah. Anyway, I had better call it a night.
It's
You
10,
look like you're
10:30 at
ready.
least back there.
Yes, and I've been busy today, so it's been very exciting. I'm gonna stop the girl. So one thing that's been very exciting. Let's stop the share.